Sehr geehrte Damen und Herren, ich möchte Sie alle herzlich begrüßen und ein Good Morning in die Welt schicken. Ich möchte Sie herzlich begrüßen für dieses Swiss-Topo-Kolloquium, das wir heute durchführen und das wir vor allem dem Thema Digital Twins widmen möchten. Es ist ein spezielles Kolloquium, wir führen es online durch und wie Sie sehen werden, auch global sogar. Es wird vor allem bestritten von Kollegen von der University of Melbourne, die am Center for Spatial Data Infrastructure and Land Administration tätig sind. Das Kolloquium ist deshalb vor allem auch in Englisch geführt. Nur die Fragen möchte ich hier vorausschicken, wir werden sie am Schluss behandeln. Die dürfen wir natürlich auch in Deutsch, Französisch stellen. Wir werden es dann versuchen zu übersetzen. Die Fragen könnt ihr in der Chat-Funktion stellen. Wir werden sie von dort dann am Ende holen. Okay, so now let's switch into English. As I mentioned, we'll hold this colloquium in English. And first of all, I would like to welcome my colleagues in Melbourne. Why they're there, I just explained, but first I would like to appreciate and thank them that they make the effort to be with us here because they are 10 hours ahead of us. So for them it's Friday evening, 8 p.m. And I think not everybody is keen to work at this time of the day. But even more, we appreciate your effort and we look forward to this input that we're getting. First of all, I also would like to explain a bit why how this colloquium came upon us. The background is a bit, I have been at the FIG Congress in early September in Warsaw, Poland. And then our colleagues, they showed us this software package. And together with my colleagues, with Christine Nayar, Jörg Lütti, Fridolin Vicky, we thought this is a great topic to look at and to look into more detail. And that's where the idea came from, that we would like to share this know-how to a wider audience, which we try to do now this morning in this colloquium. Just to give you a brief glimpse, I took a definition from the Digital Twins Consortium, what the digital twin is all about. It's a virtual representation of real-world entities and processes synchronized at a specific frequency and fidelity. Digital twins use real-time and historic data to represent the past and present and also to simulate predicted futures. But that's all about definition. I would like to leave this to the presenters afterwards. They will go into more detail about digital twins. But I would like to introduce you to our colleagues in Melbourne. And they're all active at the research center, the Center for Spatial Data Infrastructure and Land Administration, as I just mentioned. It's a research center at the University of Melbourne. And last year they celebrated the 20 years anniversary. So we'll have the chair of the center, Abbas Rajabifard, who is chairing the center for the last 10-15 years, I would say. He's involving two of his research fellows, Sohail Sabri and Penny Chen, and they're also supported by Yuke Shi, who is doing she's system developer and providing the support for them. Just to show you the faces and the program now. We have first two presentations from Switzerland, from Christine and Jörg. We thought to build a little bit the ramp up to the whole digital twin concept, and we would like to have a perspective from the public sector by Christine. After that, we have Jörg, who is giving us a perspective from a private sector on digital twins. Each of them 5-10 minutes, and then we'll give the floor to our colleagues in Melbourne. And as I mentioned, questions and answers we do at the end. And with this, I would like to give the floor now to Christine, who is going to present the public sector perspective. Maybe just to introduce Christine briefly, she's co-chair of the Office of the Swiss Geoinformation Strategy here at Swisstop, but she's active at COGIS. With this, I would like to give you the floor. Oh, presentation is there.
Thank you, Danny. Good morning to everyone near and far from my part. As Daniel said, I will give an introduction to the role of digital twins within the Swiss Geoinformation Strategy from a perspective of a federal office. I will give some general introduction to digital twin and then look at the digital twin in the context of the Swiss Geoinformation Strategy. So digital twin is a concept. It is also a buzzword, and it is used in many different ways. It originates from the manufacturing industry, where it was used to produce a virtual copy of a product with the aim to control and improve it. For example, the Apollo mission relied on a mirror system to rescue the mission in case of emergency. Other definitions are also used. For example, it is referred to a digital copy of a physical product, process, or system. This is often used in the context of BIM. It is also used as a definition of 3D city model as a representation of a physical environment and its dynamic processes, so 3D to 4D, and is also used in the context of geospatial infrastructure. So what is it actually used for, this digital twin? It is used for simulating what-if scenarios. So for example, in the BIM context, if you want to put a new building in a landscape, what does it look like in the landscape? And what does this mean for the real world? It is also bringing information to citizens, involving citizens in official processes. And it should give better insights, better decisions, and better outcomes. So now the context of the Swiss Geoinformation Strategy. So this concept, digital twin, is mentioned in the strategy and is acknowledged as an important way to gain information and to expand the ability to make decisions and improvement on processes. So, but what does this mean exactly for the implementation of the strategy? Our first approach here was to ask smart people. So we asked the EPFL, the Technical University in Lausanne, to make a study for us. I don't expect anyone to read all this on the screen right now. It is rather to give an impression of the findings of the study, that when you ask a question about digital twin and the definition of digital twin in context of geoinformation, you get a whole list of keywords which need to be defined in its context. So you see here the different keywords that needed to be defined in the context. As a result, the definition that EPFL suggests us is that the digital twin is a virtual representation of a physical system, and it's updated in real time through the bidirectional exchange of information between physical and virtual system. So in other words, you have a virtual model or a virtual counterpart of your physical real-time situation. And very important is this connection, this bidirectional correct connection, generating real-time data, for example, by using sensors. So what are also the components? This is also an answer that this study gave us. You see here, it's on the one hand, the digital models, 3D to 4D, because time, 4D plus the time, is a crucial factor. We need real-time sensor data. We want to simulate with the real-time sensor data. We need many new sources of data, which we want to put together, make them interoperable, visualize them on a platform. The study by EPFL also identified key issues and open challenges. Now, I don't want to go in too much detail about these challenges. I do want to highlight what is here in the blue box, the main keywords of the open challenges. So you see here in the blue box, the infrastructure, the data harmonization, the data models and scenarios, quality, sensors and data acquisition. And reading this, to me, I associate this very much also with work we have been doing for the, I would say, at least past 10 years, also in spatial data infrastructure context. So for example, the question of interoperability, the data models and semantics, these are very clear work and already results that we have been working on, synchronizing real-time data, integrating data from different sources to allow simulation. This leads me to the following question. On the one hand, we have, for example, here in Switzerland, the Swiss TLM 3D as a large-scale topographic landscape model of Switzerland. We also have a federal spatial data infrastructure, so the visualization, the platform, the harmonized data. So my question is the strategy a part of the digital twin, or is digital twin a part of the strategy? So do we work on the strategy implementation in terms of striving towards a knowledge data infrastructure by improving our already given components, STI or Swiss TLM 3D? Or do we have to implement digital twin as a new component within our strategy? Maybe the next presentations will give some answers to this. Thank you.
Thank you very much, Christine. I think it was a really good start to know where we're going to. And now I would like to give the floor to Jörg Lütti. He's online with us from Zurich, or Winterthur even. Jörg Lütti, he's CEO of the private company 8 Grad Ost. And Jörg will present us or give us the perspective from the private sector about digital twins.
Thank you, Daniel.
He's online, he's here. Okay.
Good morning from my side.
So can I give the...
Can you hear me? Daniel, can you hear me?
Yes.
Okay, good. And you got my screen as well? Okay, perfect. Good.
Yes,
Thank you very much. So good morning and good afternoon from my side too. Yes, Daniel mentioned we had a very interesting talk in September in Warsaw. And so I want to give some complementary information, considerations on digital twin. Thanks, Christine, for also some theoretical background information. I'm coming a bit more from a different side, so I will present now in the next couple of minutes some thoughts on how we can better support the civil society as spatial data specialists. So, and therefore, one of the core questions which triggers me since a couple of years is where our data platform needs to go. So therefore, let me start with some general thoughts about our living space. Very nice picture of village of Altdorf in the 50s. And so when you look at these pictures, you can see that in the landscape and in our living space, there are reflected many aspects. The identity, the autonomy of a village, a town, or a region. The culture and tradition plays an important role in the development of the landscape, and also the social values are established and reflected. So thing is that many of these aspects, they change over time. And so these changes are also reflected in the way how we shape, transform, and develop our living space. So questions we had in the 50s are not the same as we do have now. or if we may have in future. So there are many demands nowadays on our living space, and the cities, the municipalities or regions, they have to deal with many issues that are directly or indirectly related again to our living space. So for some years we have been trying, for example, to strengthen the resilience of our infrastructure in order to better be adapted to climate change. We've had the pandemic acted as a driver for digitalization, for new working and living models, which again have an impact on the transportations. This year, we have discussed many issues about the energy supply and how we can deal with that. And all these questions, these issues, they have an impact. But these issues, they do not stand alone as a challenge. But if we want to improve them and to develop them, we have to think and act in a very networked way. So we have to go away from silos. So in general, there is a lot of talk about the data being the raw material of the future, the most important source. So yes, I do not fully agree with this, because for us, we developed over the last years our missions from our company, that we have data, information, and processes. So what does this mean? It's a close interplay between the data, the information, and the process is key to success. The data, as a name in itself, does not solve the problems. We often have to bring data into the process, based on the specific questions we do have in this process. So we have kind of a circular issue here. We have demands from process to data, but also from how we can collect data, we can combine data to information, we can assist and support the processes we need to actually shape our landscape. So for me, this thinking is also reflected in the development of digitalizations, or from digitalization to digital transformation. I found this a very nice definition just recently, which I really support. And so therefore, if we want to harness the enormous potential of data, we need to develop a holistic view in data collection and data provision. So we need to focus also much more on the needs of customers, partners, and their questions. So that's how we can actually achieve an added value. It's not by doing what we like to do, what is nice to collect, but it's much more focused on the end user, on the people which actually solve problems. So therefore, what does it mean for our profession? On the one hand, we still will collect data ourselves with a variety of sensors. We have the third dimensions, which continues to play a crucial role, because with more information on 3D buildings, we can better assess the development of the potential of a certain area. So I am convinced that data collection will be important in future as well. Even there are a lot of potential. There's a lot of potential for improvement of the processes. So then let's talk about the information. For the analysis, here's an example of the canton of Uri. So for the analysis of the public transport accessibility, the combination and aggregation of the different data sources is necessary. So in the case of the accessibility by cable cars in the mountainous areas, which is quite important for the canton of Uri, the specific knowledge about the influence of the topography and accessibility also plays a role. So it's not only the data itself or the aggregation in itself, but it is a knowledge which has to be brought into the aggregation process as well. So, and how do we do that at the end? It's quite important to have the participatory processes where we can collect and write the different needs and demands to, at the end, make joint and collaborative decisions. And here we need the data and information as an important basis. So I spoke at the beginning about the design of the living space, and it's exactly such decisions that are made in these collaborative and participatory processes that ultimately have the influence on the further development and use of our living space. So, how can we contribute as a private sector? What does drive me to discuss about digital twin? We have now more than 3 decades of experience in digital transformation. And we have been asking ourselves for a couple of years now what the next generation of software architecture and platform will look like to better support these decisions in a complex world. So when I saw the application from Professor Abbas' group in September, I was really convinced that we have a very nice answer to our wishes and ideas here. So, and to conclude, I hope that we are now a significant step closer to these visions, and I look forward as well for the next contribution and collaboration in future. Thank you.
Thank you very much, Jörg. That came across very well. We're just still getting used to technology, but I think all is working. I've seen in the chat there are some comments, so I would like to make the hint again, ask your questions in the chat function, and then we'll have a look at them at the end. But now, with this sort of ramp up, I think that gave a good introduction into what we're going to see, and this platform has been mentioned by Jörg already, and that's what we would like to look into now. With this, I would like to give the floor to the team in Melbourne. And I'm not sure, maybe I give Abbas the floor first so he can introduce his team and what we're going to see in the next 40 minutes or something. Abbas, can I give you the floor?
Thank you very much, Dr. Daniel. Can you hear me now?
Yes, perfect.
All right, wonderful. So thank you very much. I would like to start by acknowledging and thanking Swiss Topo for the opportunity that you have provided to us, to our research team, to be with you today and sharing some of our experience and lessons, and also the new work that we are working on the research and development of a new innovations. I would also like to acknowledge the both colleagues that have just presented, Dr. Christine Nair and also Mr. York, that you have both provided very nice introduction to what we are going to share with you a bit further on that. You already actually put a very good set the scene for this conversation, and it's a timing right how we can leveraging off the type of capabilities and technology can help us to better serving our wider societies, and at the same time also creating opportunity for our market. So I'm going to present and share with you today some of the foundations and also some of the case studies and also the capabilities that can be, adopted today in your activities. Christine has actually indicated, is that going to be a strategy and then having digital twin as a component, or it is going to be a digital twin that would actually helping us with a strategy? Which I don't want to answer immediately into that response, but you will be hopefully seeing this. And also I will be sharing that our views on that. But it is something that we can start and leveraging off. And in fact, the whole idea is, how we can afford to not have this if today we can integrate. And York has indicated and has finished with a very important message here, that the role that all the parties can collaborate with each other, from the government, from the private sectors, and also, research and development institute, academia, that can actually again combine today together and deliver that. So we're going to share with you some of those elements. I'm going to present, supported by two of my colleagues, Dr. Sohail Sabri and also Dr. Benny Chen in this particular. I put that one as a starting with empowering land and geospatial agencies, a new era. And again, all of us, we have we have studied in geospatial and surveying as a foundations, and I mean, heavily our work have been around modernization of the land system. And again, how we can push the technology and adopting and incorporating those capabilities into our operation. I used to be, the head of the production line of the national base map. And now we see this, how we can integrating this into our production. And at the same time, while we are serving our agencies and also wider societies, we can actually bring the more intelligence and smart services into this. And then the system become more smart and also getting more mature as we interacting with the system further. I also put the Sustainable Development Goals logo here because this is another dimension that we can integrate rather than just as an ad hoc responding to this. We can integrate that as part of the system that can serve us and providing us with the capabilities and improving the resilience and also the way that we can mitigate the risk. We can also forecast and simulate the areas and at the same time having a live system that supporting our decision process. So with this, we're presenting our research center. Benny, please move to the next. So our research center, as Daniel has indicated, we are just over 21 years in operation now. And our focus have been always around modernization of the land system. It is in particular how we can leveraging of location and addressing to servicing wider societies and government as part of the societies. But in particular, not only the foundation and the knowledge into this, but also applying the research into the operation. So therefore, there have been series of drivers for us. Our both speakers and also Dr. Daniel already have provided some of those elements. And all of us and all of you have, I'm sure, actually agreed, and you have also series of elements why today we need to focus on this type of element. This is just a number of those foundations. I mean, I just highlighting a number of those. I mean, digital economy, it's something that I believe in particular after the COVID or coming out of COVID, I mean, and now we see that the impact, the negative impact that actually had in all countries' economies, and now how we're going to recovering our economy in that sense. And also at the same time, the effect that actually already provided to our infrastructures. So therefore, we look at to the way that we can better preparing ourselves to be more resilient in that sense. So we look at to the emerging market. We look at to the safety and supply chain. And at the same time, the role of series of elements. I mean, in particular, we're talking about connected and also automated and shared services. So we're talking about distributed environment. At the same time, having a live system, having a sensor network, data that being captured and flew into the platform. And then we also at the same time addressing, supporting, and the sustainabilities, and then adopting series of latest technology, IoT, AI, AR, and also smart utilities, 3D, 4D, and what Christine has indicated about digital twin, about the 4D, I would like to just add into that. We go into the ND. It depends to how much information we can add. So now we can have that ability to adopting and integrating as far as actually, again, we can go and we want to unbundle any type of rights, restriction, responsibilities with any type of ownership, land, and other mapping into this. Our motto across this is always to look at to the challenges that we are facing as societies, as well as also connecting those into the global market and bringing the opportunities that we can serve that. So it is about bridging the gap from local to the global level. Now, the center that we're representing today here is 21 years in operations. focus of our capabilities have been, again, started with modernization of the land and always been as a core focus for us, building information model, modeling, integrating, and also adjusting that one in line with the data infrastructure, as well as also series of capabilities to bring to analytical tools, to bring that type of elements that actually can provide indoor and outdoor connectivities, to provide us and in the portable devices and the way that we can interact while we are collecting. Immediately we can actually transfer series of auditing and also as well as a series of testing. We can do that when we are in the field to collect those, or different sensors that we collect information, and then we reduce the number of processes, and then we bring that. The reason is to responding to the series of challenges we're facing in our societies. We talk about complex environment and intersection between land and also the marine environment. Again, depending to the type of jurisdictions and also the complexity in our infrastructure, in the buildings. But at the same time, we see more challenge also coming up. Again, about the climate change, about the challenges that we see in the market. And it is in fact more related to the asset management, and it's coming through this. And the study actually in Australia have actually demonstrated majority of our infrastructures are going to be on the repair status by 2030. This is again, when we look at the sustainability at the same time, how we're going to respond to this, but at the same time, how we can monitor the health of the infrastructure and also preparing ourselves to supporting that, mitigating the risk, improving our infrastructure, minimizing the type of investments, but at the moment, or maximizing the return on that. So therefore, when we look at to this, we're realizing this, that the lack of an ecosystem of open, harmonized, and interoperable information models, and also data sets across land and built environment, natural environment. If you look at to the right side, you can see, depending to the status of our work. Benny, can you please just one step back? What we would like to look at it is what you see on the right side of those images, depending to the R status, from the paper to the current digital to the digital twin, from 2D to 3D or plus, and then from silo-based into the integrated approach, into the, rather than to be isolated, to be more accessible, and then rather than being ad hoc, to become more standardized. And then we have a trusted. So therefore, please now move. Then we can look at any type of new infrastructure that we're going to build. We need to look at that, how we can put into our design parameters that we can deliver more sustainable, resilience, and cost-effective infrastructure. So these are the foundation that our research center have been working, and we are very pleased that we have actually been working and interacted with more than 60 countries already. And the overall paradigm for our work and what we believe that is actually helping us with the interconnected future that is going to be for all. So it is about how we are connecting the smart infrastructure and smart cities into the sustainability, and also integrating that one as a fundamental, as a baseline, which would be cadastral information. It would be 3D also, again, the basis map, and that we can use, and digital twin. So therefore, I think this is why digital twin as a platform will be part of this strategy, that how we want to evolve to our jurisdiction, to our strategy. If we did that, then we can look at to the interconnectivities. Let's actually look at to this. From physical world, we're going to the digital world. So in order to move through this journey, we need to look at, again, from, this is what I would like to highlight, the cadastre, the role of the cadastre, from the two-dimensional into the two-dimensional, again, spatially accurate, the parcel fabric, into the 3D parcel fabric, into the 3D digital. The reason we actually distinguish between 3D parcel fabric with the digital cadastre, there have been series of agencies and countries or jurisdiction have raised that, oh, we do have the 3D because they put the height. But that's not what we mean by this. we would like to have a truly 3D that actually would facilitate, in particular in the urban system, but at the same time in the rural area, also for the underground assets and utilities. The study that we have done with World Bank, and we've been actually again as a research partner with World Bank to develop a roadmap to improve the resilience status. And that's actually any dollar investment we arrive by testing again in 25 countries. We've done that type of studies and arrive into the $3 return. This is for the countries with a mature standing. You can imagine that if this is actually going to be for other jurisdictions that are not mature from the infrastructure or data perspective or data infrastructure, you can imagine that actually that return would be much higher. But the most important is about IoT and linked data. It's a connected platform. So we're talking about the fully integrated system of systems, and at the same time also providing capability of interactions with no limit into that as a portabilities, at the same time also engaging the citizen as sensors into this. And then we can actually look at this to delivering and supporting of a digital economy, returning more services into the mix that we can get. But in order to do this is just a quick snapshot, a journey from the paper-based to digital to three-dimensional and into the high definition live data and into the indoor and into the digital twin. So therefore, we are talking about integrating all those high definition information rather than having, the cadastre with the 2D or even with the height in our database. We can actually go now inside, interact with that, apply series of computation and applications, utilities, air qualities, energy efficiencies, and also safety, situational awareness, all the assets that actually we can have into that, supporting our operation, supporting our living to going forward. This is the message and why and how the digital twin can be adopted, can be built into that. We have been developing series, and the platform that we're going to demonstrate here are actually again capable to, first of all, they are open source. It's also capable to deal with any type of formats, to deal with any type of, the projection system, and at the same time providing that. We have done a project in our Victorian state here, and we managed to get over 1,200 data sets actually coming from 20 departments into the mix and providing series of different outputs that can support into the different type of application, and not only application for one individual agencies as a multiple dimensions or multifaceted use cases scenarios. In fact, we have mapped over 130 scenarios to what are the things we can support into that, and then we can provide, interact, and bring those kind of capabilities under control and also in the hand of decision makers and practitioners in the field. Into the digital twin, there are three major components: from the data perspective, from modeling perspective, and from the application scripting into that. And then, of course, then we can create the knowledge, we can create the analytics and simulation and visualization into this. So therefore, we are dealing and integrating and how we can harmonizing this into the system. And then we providing those kind of connectivities into the field when we capturing those information. And then we actually putting that type of auditing and also testing, validation rules that can be adopted into this, and then applying that the system can interact and learn from AI in particular, and also from IoT into the mix that we can get. So we're going to also, again, what you are now seeing here is a very high level system architect here, that it depends to the type of capturing information, either it coming from the direct surveying, or we going to the scanning capabilities, or going to the mapping with the drone, or we taking aerial photography in that, or using the imageries. So you can actually imagine any form of the capture information can be also integrated, provide the solution integrated with the system. And then what we have developed the tools, in fact, what we have tested in Victoria, and also providing the mechanism that would facilitate the speed of interaction with those kind of integrated approach with a system that has actually significant heavy load of data, which would be very difficult to move. But the way that we now develop tools to, again, they're putting the approach and also patchways that would support the speed into the interactions that you can do and utilize your even mobile phone to moving into that, integrating and applying series of elements. While different agencies but providing that without interrupting their businesses. And then you can apply into top of that to get in live system. And the system can learn from that type of interaction. And then providing solution and also option that you can have for simulation and taking the decision. A number of application domains that we would like to also share and touch on that. So one of the elements is about multi-source integration, modeling and simulations, and then also about the advanced urban analytics, and then augmented virtual reality capabilities to bringing also when you put the building, you are able to get any floor of the building, any type of building that you have, getting the floor out, examining that one, applying series of elements into that, interacting with that, returning back. So that's a type of live because we integrating building information model with the digital twin with the 3D cadastre. So therefore, where you are at the moment, and you can imagine actually the live into this, and I was also again had the opportunity to listening to the strategy that your colleague have presented at the Warsaw FIG Congress about the future of the Swiss Topo and also a strategy for mapping. And I was very pleased to see a number of attributes that they're already part of the strategy. But we can now see a number of those can be brought forward or can be realized earlier than what you're expecting into this. Let us we share with you going through a number of application areas, starting with digital twin, going to 3D cadastre, a couple of examples in disaster management, supporting urban planning, and then we look at to the integrating IoT and real-time data analytics, space management, and sustainability and resilience. This is just a quick snapshot of number of those, just to giving you a better evidence and also confident that we can progress and do that one as well. What we have done, and we'll be going to touch on a number of cases today here, is a number of examples. The Fisherman's Bend in Victoria, the technological hub, which we have in Victorian government here, and then Sydney Science Park digital twin, Central Jakarta digital twin, Singapore City, the case, as well as also the Helsinki digital twin. And again, and we're very pleased to also going to share with you today a bit of example and also exercise that with the support of colleagues York and the other colleagues again from Switzerland, we've now managed to get a number of activities utilizing your data sets and then demonstrating that in Zurich. So therefore, we are going to demonstrating to you with your data sets that how that actually can work. This is the digital twin Fisherman's Bend. This is a project, as I've mentioned, what you're seeing on the bottom right, the live data system coming from the transport, the tram movement in the cities, the modeling and also integration of the series of models and analytics, and in particular, the areas that can be integrated, again, the number of solutions or the cases that requires multiple agencies to interact to answer the solutions into that base. Let us be just showing you a short video about what we mean by digital twin Victoria.
So Abbas, can you hear the sound?
No, I'm not hearing that. Maybe you need to re-share that.
Okay.
Sorry for that. Just let us share with the voice and the sound onto the videos. So now let's actually, that was only the snapshot of what we have demonstrated and managed to get over 1,200 data set. And in fact, as a result of that digital twin project we have done with our Victorian government as a proof of concept, government have managed to get $42 million to support and scale up that for whole Melbourne. And currently there is a project on digital twin Victoria that Victorian government land agencies is responsible in collaboration with other agencies to run and expanding that elements. In Jakarta, we have done it the same. We started again dealing particularly with a series of challenges that this major city and also dense city and a more populated city in central Jakarta working on. So we started focusing on elements into that. And then and in particular, we brought together the live data into the system from traffic control as well as also air quality. In addition to the high rises, they have in this center Jakarta itself about 2,000 high rises, that the way that they needed to register those and the challenge that they're facing with the registrations of those strata, and also again the form that they need to look at for any elements into this. Now we have integrated that one, also integrated with the land registry office, with the legal system behind this, to providing capabilities that would support the governments that actually better understanding and integrating and examining the parameters and also validation for the approval process into that. With similar cases also, we have moved to applying that into now in Sydney, in the Science Park, which is the planning scheme for the New South Wales government to focusing on building a new areas. So we started focusing on that with the areas from right at the beginning to scaling up that type of constructions, going above that, and also bringing any type of planning scheme, supporting the evidence, as well as also getting approval process done. Our research team have actually also helped to develop the electronic planning permit assessments in the automating that, as well as also again bringing series of elements related to the associated infrastructure, depending to the type of infrastructure they have, to bring that one and interact with each other. If we now move to the Helsinki, you may have seen online the case of the Helsinki 3D platform, and now what we have gone through that, we actually again we have taken this and we have gone through those, going inside the building and also outside and interacting with those elements, and at the same time providing series of analytics as a life into the system, which is going to be 2 steps beyond what they already have as part of the plan to expanding the whole city. But now opportunity to bring this by integrating into the BIM and having everything to be under your control and integrated with the surveying right from the field into the system and interaction. And also we have developed tools to also identify and positioning, which is up to 1 centimeter, actually again, accuracy. Our research team have been for the last 20 years more focused on data integration and also the creation and also positioning, to making sure that all the rules and regulation, which in Victoria itself, we have about 120 parameters that need to be tested and automated. And we also have developed a roadmap for Malaysian government that then, and we tested in 2 cities, that now they have about 40% reduction in their process of land surveying, collection of information, bringing back into the 3D cadastre, into the system, and in particular going underground. So that is the part related to the underground assets and utilities and in infrastructure on that. What we have developed over the last about 10 years, we have been more focusing on cadastre and mostly on modeling and also integration from the also rules and regulation into the institution legal frameworks, as well as also surveying methods. What are the ways and can be integrated into the mix, as well as also we bring in that integration into the model that can be adopted depending to the type of model that you're adjusting. If it is going to be, for example, the different type of model LADM you want to use, or I know that Swiss also using their own system and modeling, and how that type of modeling can be integrated here. And then from the data integrity and also query and analysis. And this is again, as a holistic approach, dealing with that, providing with the opportunity that the third dimension is not just a digit inside the database. It is coming and integrated with the BIM inside your system, and the system is capable enough to run. Then we're going to look at today if it is going to be as built, the city that already many buildings is there, or is going to be from the what you have a plan to going forward. So there are different approaches dealing with that. So maturity level for the cadastre, from the 2D digital cadastre going to the 3D digital fabric, and then moving into the also how we're going to build the digital twin in top of that, and also integrating that one with the series of sensor network into the mix. And then into this, having underground, above ground connectivities, indoor and outdoor connectivities. And I think that's what we are bringing, that high definition also role that we can capture, and we will be showcasing to you our building and how we are doing that from indoor and outdoor, underground and above ground, and have a holistic approach. Now let us actually go to the live system to demonstrating the Zurich into that. I would like to get Benny and also Sohail to helping us with this. Over to you, please.
Sure. Thank you, Abbas. Good morning, everyone. So my name is Benny Chen. So I'm a senior research fellow. I've been working with Abbas and Sohail in the past few years with a focus on the digital twin. So as Abbas has mentioned, so we spent quite some research efforts to develop our own digital twin solutions. And we, with the help with our colleagues in Switzerland, so we quickly put up like a prototype system and to demonstrate the usability of our system in Zurich. So this is the main platform. So we have many capabilities here. So let me just turn off this one. So this is our case area. So we can easily load some the existing data sets, which is publicly available. So we directly get the data from the Swiss the data server, and we also so this is all the 3D buildings, and also you can see we have like a very high resolution the 3D DM as well, so which is serves matched with the 3D building really well. And we also have the 3D the vegetation layer, so which looks really, really great. So this is all the 3D digital models that is absolutely important for any digital twin platform. But digital twin is actually more than that. So we leverage our current capabilities. We quickly put some like new features on top of it, so we can see how we can actually add more values by incorporate different types of data layers into one single integrated system. So the first one I probably want to show you guys is some like live traffic information. So this is also a really good collaboration between our research center and another massive the geospatial data provider here, Map. So we worked with them with like different types of APIs. For example, so we can, let's say I choose Zurich here, so, and we can directly load, for example, the up-to-date the traffic jam factors for the entire city. So pay attention to the timeline here. It's actually, so we're kind of like collecting the data every 10 minutes. So the system can load up to the last 1 hour the traffic situation in that area. So, and you can see the different, we have like a legend here to indicate the different road segmentation and about their current traffic jam situation. So beside this, we also put some efforts to do a quick demo of how we can actually integrate the BIM driven 3D cadastre model into the system. So let me load it here. So if I want to fly to this area, okay.
One of the reasons we actually moved to this, to just making sure that while we are demonstrating some capabilities are with your data set and your city, that you can see your data actually are already ready to be able to be connected to the system. So it's not going to be actually, again, a lot of, for example, ambition as a plan or steps need to be forwarded. So you're already ready for that. We just plant one of the building inside, which hopefully we can get permission later, but we just wanted to demonstrate the capabilities. Over to you, please.
Yes, as you can see, we put this like a sample 3D cadastre building here, which is currently overlapping with the existing one. So in our digital twin, we can easily do some scenario planning. For example, let's get rid of this building, and also get rid of all the neighborhood buildings, and so we can have like a clear view of our digital model. So if I load it here, and so you can see it's really well into the existing 3D 3D city models. And we have, because as I said, our current 3D cadastre is based on the beam. So the beam gives us not just the for example, the parcels, the lots, but also give a lot of, for example, like the floor, the slab, all these sort of things, the stairs, a lot of information we can actually control. So if we want to include into our system for visualization purpose or for query purpose, so all this sort of information can be, can be incorporated. So
just
what
on
we
that
can
one,
do,
Benny, if I may, I mean, when for those of colleagues that are aware about the LOD, so majority of system actually going to be, or these jurisdictions have done up to the LOD, for example, 2 or maximum 3. What you're going to see here is LOD 4, and you're going inside and getting more interactions. It's still very easy and also capable and fast enough to interact with that. Yes, please.
yes. So as long as we convert the beam model into our digital twin platform, and we can fully manipulate these models. So once they manipulate, I mean, so we can do the the rotation, all these sort of like the 3D and visualization means, so that we can apply to it. For example, we can create styles for it. So let's say, so this is our building. I want to create like a 3D floor, and we can, based on the, for example, different floor number, we can choose like a different color ramp. We can do different configuration to to increase the difference the styles for the visualization purpose. If I click save, and you can say we can, so that means each individual components inside the beam, it can be manipulated. So, and we can attach not just the original beam information, but a lot of like cadastre information on top of it. So we have separate the physical, the 3D digital model with another actual 3D cadastre information database. We kind of like join them together, and we have a lot of flexibility to connect or to integrate different types of information together into the system. And we also have, for example, we can do the explode the view. So we can just, explode the entire building and put them back. So this, sometimes we found this tool quite useful for us to have like a close-up observation of the details, because otherwise all these sort of floors are sitting together. Sometimes we need somehow break down, and we can have a good observation. And we can also have another like a slide view. Let me just put this, let me put this back. For the
One of the
slide view,
challenges about the banking,
Yeah.
sorry, about the insurance and also the loan, the banks that actually again providing the loan and the title. So that's a title search, and again, one of the service here we had to respond to that to the bank is related to the what are the flats that they have borrowed a certain level of the money from the banks, and they wanted to see in which building, and then how much of that is going to be again under the which insurance. So those are the elements that now be integrated and is provided the service with this.
Yeah. So we can also do this sort of based on the cadastre information. We can, for example, we can query what is the proper value range, and we can also determine, okay, so what will be the, for example, the floor level. So we can, it's kind of like a mix of different types of information, and then we can apply a query. And immediately all these sorts of selected information will be highlighted into the system. So we can look from the different sides. And then if we click any of them, and we will be able to query all, the information we attached to the model. Yeah. So about the cautious
do you want to
times,
mention about the planning here?
Yeah.
Sure.
So can we move on back to the slides? I think we have more information on the slides.
Let's go to that.
Yeah.
We go back. It just wanted, again, we wanted just to quickly, again, for this seminar today, we wanted to just testing some of your data that we just giving you confident that how that actually been working, and it is actually the system is capable enough to running that. This is just a quick process from the beam into the 3D cadastre, from the how we getting the data into this, from the IFC version integrity, and then we also identifying the lots and common properties, integrated that with the boundaries creation, and then into the 3D tile conversion, and into the enrichment, and then into the visualization, the queries. So it is the process that we develop an automated series of steps that actually going to be happening behind the system to get to what you have actually have seen. At the same time, also for those existing plan that you have, or the buildings that you have, from the 2D to 3D floor plan, and again similarly from the how that actually be converted from those kind of CAD file into the system, and then arriving into the digital as part of the digital twin into the system. Therefore, again, going back to what Christine was saying about is that going to be a system giving us the strategy, or that it is in fact your strategy that actually demonstrating having that type of elements part of it, and then starting with the proof of concept or scaling up that one as part of the plan. And we usually develop the roadmap or contributing to the roadmap, and how that would actually be coming in parallel. And the capabilities and connectivities, and in particular, I just saw that one of the message that one of the colleagues online has indicated from the planning schemes, that I think that type of elements, which is great to know that you're actually, again, the planning activities is doing a lot of work related to this. It is great that actually, again, bringing and integrating that one into the solution and providing that and much faster means to arriving into this, and then going further on that. Continue, Benny, and then Benny can, Soil can actually look at today some of the capabilities into this. Maybe I'll just mention this, Soil, then back to you. It is mostly the recent work that we have been working on the underground, and it is in fact because of the complexity with the underground, again, the spaces. For example, right now we are working with also Singapore government, and again, series of elements because of the underground spaces, or the space that the ownership, and also the integration of those elements, that how that, and we usually work from the modeling to the, again, integration and visualization into this. So you want to go back, continue on that one? Yeah.
Previous slide, Benny. Can you hear me? Oh, yeah. Okay.
Yes. Yeah.
So perhaps I think in continuing of the conversation that Boss and Benny actually presented and discussed about the role of this digital twin, which is spatially enabled, and then it uses the cadastre system as a base or foundation. Perhaps I can see this is a distinction of the urban digital twin that you can see with the other digital twins, because we are not using a game engine. We are using the cadastre system, and is not 2D and 3D. So as you could see that we actually have used building information modeling at the back end. We actually had a pipeline of conversion of that to the GIS environment to be able to be connected and integrated with other type of data, either planning zones that I will be presenting to you, or the, real-time data and sensor data. Okay, so as you can see here, the current planning, spatial planning process is PDF based, at least in our jurisdiction. I don't say this is happening in all around the world, but at least in our jurisdiction is PDF based, 2D based, complex and fragmented business. We actually do spatial planning and also statutory planning. That means building, applications, response to the applications and approvals. So our digital twin should be able to actually demonstrate or at least enable the planners for the 3D based and standard and coherent way of assessment and actually evaluation and approval. So this is what we actually we are trying to address. And one value that I can actually strongly justify on this digital twin is that this is connected to the land administration. This is not something that very separate from the land registry or land subdivision, and then it goes to a new platform which is very disconnected. So this is a connectivity, and also is actually connected to the life cycle of the building and infrastructure development that we will be showing to you.
Benny, do you want to move to skip the from the, or maybe you want to just run at the flood and then we go to the planning, continue with that, and skip the next one?
Sure. Okay, so I think
just go to the I would actually go to the next one, to the planning.
So this is, I'll go to the next one, go to the planning one.
Yes, that's leave it to here.
This one is good.
No, go back.
Benny, if you go
go back to the air pollution.
Just one example here for spatial planning and addressing one of the challenges. This case is the Singapore government, where we actually work with the Urban Redevelopment Authority, National Environment Agency, and Singapore Land Authority. Now you can see that we actually have the Singapore Land Authority as the data provider, and then the other departments are actually coming and leveraging that fundamental data or foundation data for a particular type of analytics, which is demonstrating a pollution movement over the high-rise buildings. As you appreciate, the Singapore is a very small island where the aging population is one of the challenges, and haze and pollution is one of the issues that they have to respond. And we actually supported them to actually conduct microclimate analysis over the platform and demonstrate the impact in different time frames, and to be able to actually protect their aging populations. So this is one example of spatial planning, and at the same time is mitigation and real-time analytics to be able to address the potential disasters to the population. And then next, we can actually talk about some use cases in the planning space. In our case, in Victoria or Australia in general, we actually have descriptive planning, and in that case, we actually have a diagram-based type of communication, and also text-based or table-based communication with the planners, which is very difficult to understand. What is the development and design overlay in each part of the neighborhood, which is going to be developed in the future. And as you can see here, we actually developed a tool to support the decision making through the conversion of that text into the 3D visualization. And even this in the edge level of each building, or in the vertex level, you can actually make changes and then run impact analysis to assess against several aspects in terms of the environmental impact like shadow, or the economic impact like the yield of the building or gain, and even social impact in terms of the number of population or the type of population that it will be generating for access to the social infrastructure and physical infrastructure and service requirements. And then next is about the collaboration of this platform with third-party tools. The case here is how we can actually connect this with highly capable tools like the one that Arup actually provided to us for the pedestrian movement. The work, I mean, the tool is pedestrian movement analytics, is type of agent-based analysis, and then we actually added the spatial analysis layer to the case of where to put the public transport station in a place that we can actually avoid the disease transmission to the people. So whether the transportation should be in the single lane or double lane, and what are the implications from the public health perspective. And then we actually have other capabilities like integrating the last and current and future data in the city. Urban morphology, as you can see here, we actually have buildings in a white color. These are the current buildings. We actually have cubes color coded, which is planning, a precinct structure plan or detailed plan, which is happening by 2050. And you can see the morphology of the neighborhood based on that. And then those blue buildings are the one that's submitted to the government, to the local government or municipality, to assess against the objectives of the planning. And this way you can actually understand how we are, deviating from the planning. And also for architects, how we can actually put the mass design of the building on the reality to assess against the current situation. This one here, it shows that one of our new campuses that is going to be built in Melbourne CBD in a 7-hectare area, and it actually overlaid over the reality so that you can actually assess against the current situation and understand the impact, the visual impact. And then it can be actually used for other purposes like the coverage of the 5G network or any other type of coverage for planning of the infrastructure development and utilities. And one use case I just want to mention about again, this is the kind of value that we can add, about the scenario building and strategic planning. In this case, we actually have water sensitive urban design, back to the case that I actually explained to you about the actually exactly geodesign. This is exactly geodesign, which actually we work with the landscape architects to develop this work. And actually this is we actually put the current road networks, the future developments, and also the the catchment areas based on the flood modeling. And then the case here is that we actually we plan for the creating the road networks, and then see what is the impact of that road networks on the stormwater capacity. We can actually make changes on the road networks, saying that we need the width of 10 meter, what is the stormwater capacity, and then on real time we can get the understanding of the impact on different catchment areas. So this is the research and development that we actually conducted to demonstrate the value of digital twin, where is connected the photo mesh, the satellite images, and so on and so forth. And then it comes to the IoT spaces and occupancy, and that I pass it on to Benny to explain more about this.
I'm just conscious of time, Benny, because I would like to get only the next 5 minutes to finish it off. If I may just quickly, now, what you are going to see now, this is our, again, floor, this is our office back in Melbourne. What you see here from the real example and also scanned, and also the movement and the scanning and also positioning, all of them integrated together. So IoT into the mix, and the series of sensors inside the building capturing information to be added into this, which you will be seeing next to that. And again, what you're seeing here from high definition and then moving indoor and having capabilities to integrating and applying application domains. Go to the next. What you see here, again, the example of the 3D scanning. This is not the sensors that is attached to the person movement. So we have actually developed tools to better actually again monitoring of any type of movement into the system that would help us. And in fact, one application of this is now utilizing by this technology in the health and hospitals for the fall prevention, for example. And we have just got a new funding to look at to the series of elements for aged cares to actually apply that type of thing because of capability of indoor and 3D, actually indoor and outdoor capability movement, which we can get. And that's Benny himself inside this that is actually moving. So next one, please, Benny. So, and I think another element is about the what we call it artificial intelligence of things. So not only IoT, we actually look at to AOT and actually again to bringing series of analytics. This is our new building, what you see here, and also the spaces that we are utilizing, and also occupancy here and energy efficiencies, which are all integrated in one system. So you can actually see that now we can bring and connect with the different departments, the data that they capturing information, capturing that can come through the platform and apply into this. And then a space management can also again providing that. Let's we get into one of the building, and then you can see how we are seeing that indoor, and then we are able to measure, we are able to assign elements into that and move. And now we go to the next step, and this is what you see. This is our campus. This is the way that we are now helping our virtual campus by utilizing the indoor positioning, plus also integrating that one with a series of analytics into the mix to providing assessment. And also we now focusing on a new dimension, which we call it digital twin or human digital twin, which is integrated with the physical space that we convert into digital. So therefore, it's becoming somehow a sound of the fully avatar. But then we are talking about the human digital to the, again, digital twin that we can integrate and provide. I'm going to finish it off by just a couple of examples of some of the challenges that still, as a just to be aware, they also related to the data itself, related to the technology and the ways that also those elements can actually be integrated through the governance. And of course, depending to the agency is going to contribute to your journey and how that type of arrangement is going to be happening. Of course, the capacity building and also the awareness and scaling up and of the capabilities of everyone into the system. And one thing in order to be successful is a close collaboration between the government as a strategic or as a providing the guidance into this, and also engaging the private sectors for bringing and value adding into the system with also innovation and apply type elements into the mix by researcher universities, and then identifying element that actually can provide better approach for you. So by this, I would like to thanking again the opportunity that you have provided to us to sharing with you, and I hope that those provided you with some insight, and then we are ready to answer any type of question you might have, and we also welcome any type of collaboration. Thank you very much.
Thank you very much, Abbas, Sohail, Benny. That was a very impressive demonstration of your holistic platform. Sorry, I have it double here. So maybe I've seen we have a few questions in the chat. Thank you for those. I think they also like to emphasize this holistic approach, which I also thought that's a really valuable thing to see, not only data, but then we also can integrate all the procedures. When I look through the questions, I think which are relevant, maybe the one from Peter Hayo. Peter, he's active at Swiss Topo in the National Geology. And his question is, how can you go into the underground, not just underground buildings, but more from a geological point of view? Can I give this to you, Abbas?
Benny or Sohail, do you want to answer that? Is that okay? We answer, or Daniel?
Yes, that's fine.
Yeah. Well, I think in terms of underground, we actually have been working with our colleagues on the geothermal and the data provided and information that we can actually integrate. The platform is capable of integrating the underground and visualizing that. And then the next level is how that those things like geothermal can impact the building energy performance or city energy performance. That is in the pipeline of the activity and is completely possible from our side.
Thank you
Benny,
very much.
do you want to add anything into that?
Yeah, sure. So for underground, I think one of the biggest challenges is also related to the visualization, because a lot of existing tools on the market now, so they do really nice job for the the above ground visualization. But for the underground, there's so many from the image rendering, from the 3D model rendering perspective, there's so many challenges. So we adopt the open source solution, and we will try our best to do all this sort of visualization in an online like a platform, so everybody can access from anywhere. So that gives us a little bit more challenging actually to enable this sort of underground visualization, in our digital twin platform. But we're working on it, and we have already achieved some good results by far.
Thank you very much. Then I think we take the next question from Andre Steilein. And he asked, the urban planning use case is already in operation by private companies. And his question is, where do you see the added value?
I actually apparently answered that, but again, I just re-emphasize because first of all, I am an urban planner, and also I'm working here as a digital delivery lead in this research center. So I have been working and researching on planning support systems for 10 years now, and I'm quite aware of the planning support systems available in the research and market. And I know that the challenge of the planning support systems or any tool is that either they are not fully geospatially enabled, or they are not connected to the before or after activities, including land administration or construction. But this platform is completely connected, and that is the new value that is actually offering in the market.
Very much, Sohail. The next more remark is from Tom Klingel. So he has a hint to maybe for further reading. Reminds me strongly of Carl Steinitz's geodesign methodology perpetuated with current computing methods. So I think it's a good hint for our for weekend reading, maybe. Maybe I just have a question from Maria Kloner. She gave it to me on a little sheet here. And her question is about data harmonization. How do you deal with incomplete information or different quality in different areas? Repeat again.
I have a problem of hearing that.
Benny,
Okay.
I can hear that. Benny, have you heard that? You are muted.
Yeah, can you say it again? I didn't hear very clearly.
Yes, I try again.
Yeah.
The question is about
Thank you, Daniel.
data harmonization. How do you deal with incomplete information of different quality in different areas?
Okay, so yes, we spent quite some efforts working on the multi-source data integration and data harmonization. And yes, the different level of the maturity of the data sets, the different updates frequencies, they are all kind of like in practical, there's all challenges. So the different ways to do this sort of the data integration or data harmonization. And we recently, so because we come from the geospatial background, a lot of our data is actually, based on the regional database, so we have like really good format actually. But when we do the data integration, so that we can see there's so many examples, this sort of data and heterogeneity issues. For example, the same kind of data sets, but they totally, with using different attributes, but they actually describe the same thing. So we, so in our research center, we actually, did some pioneer work using the ontology to try to resolve it from, from the using define like some ontology to do the harmonization, so we can describe the schema of as like specific domains, and then we can actually map the different types of data into that like a shared ontology, and then our model can understand the data represented in that ontology, and then all these sort of following analysis can continue. So that is one of the approach we adopted. And also is from another perspective, if we're talking about the real-time information and how the real-time information can somehow work with the existing, for example, the traditional geospatial one, that is also a huge challenge for us as well. So we come up with some idea, we develop our own kind of, the streaming engine to do this sort of in the real time, we do the data cleanup, data, what they call it, the transformation, and in a way that our system can be, fully, leverage this type of 3D or real-time information. So from the visualization perspective, so I think that the challenge is totally resolvable, and we have already demonstrated this sort of capability to do this sort of integration of the real-time information, 3D information, different type of information. But on the deep level, so how we can actually break, these sort of connections between different sources. So that is something we are currently also working on with it. And also the ontology sets a very, really important role in our roadmap for this.
Thank you very much. I think that shows clearly the challenges that you're going through. But yes, I would like to go on to the next question from Andre Streilein as well. Could you elaborate a bit on the value of geodata feeding your system, in particular with respect to quality? Sorry, I have to expand to the quality requirements.
I have difficulty hearing.
I'm not sure. Can you hear me, Sohail and Benny?
Benny, have you heard that? Sohail, have you heard that?
Yes, I can hear
If
you.
any of you have heard, if you want to respond to that, please go ahead.
It's also a question which is in the chat. Maybe I just repeat it again. Could you elaborate a bit on the value of geodata feeding your system, in particular with respect to the quality requirements?
Well, I think is the value of geodata. Definitely, we consider that as if you are actually referring to the quality of the geodata, definitely the higher the quality is, the more important for us. And we always, we try our best in our pipeline of filtering the geodata, try not to use any sort of noisy data or low quality data. But at the same time, we provided the capability for any user to load their type of data, and then they can actually leverage the other available publicly available data and integrate. But having said that, we should be considering that the data which is being loaded by the user either is a data custodian or I mean the user, any other user, the reliability of that data and quality is on their responsibility, not the responsibility of the platform.
Yeah, absolutely correct. So as Sahil mentioned, so our digital twin is an ecosystem. So everybody can, be, so have like a role of a data provider. So, so when we let people bring the data into our system, so that's one very important step is to do the metadata enrichment. So that is absolutely important because without, if we're talking about the data quality, the quality of metadata itself is so important. So in Australia, we have a nationwide project called ORIN, an Australian Urban Research Infrastructure Network. So we use a very similar, the infrastructure design like ORIN, but we also put a lot of efforts, to let people to do the metadata enrichment. So without clearly enrich the metadata, so your data basically useless. For the data quality, I mean, data quality itself is always arguable, right? So there's no like the perfect data. So data is, continuously evolving. So the staging of data is something we also contend. We put a lot of concern as well. I'll give you an example. For example, the census data in Australia, we have this sort of sensors come into the system every 5 years. So we kind of like also do this sort of staging of the data. So if, for example, your data currently got some issues, so you probably, from the data owner's perspective, you should also mention this very clear. Just like give like warnings to all the possible, data user or data consumers. That is also very important.
Just on that, if I may add, because I saw one of the comments was related to the platform to be used. Yes, it can be used as it is as a platform as to servicing different agencies or different groups. It's not just for research, it's a practice, and it's actually again servicing the agencies. So it can be used and it can also, as Benny has described, adopting or bringing your data into the system, integrated that and apply, and also providing new capabilities as you see fit in your processes. So again, this is something that it can be scaled up and it can be adopted into different forms, and also adopting with a different type of information that you have, which can be looked at and tested and then brought this to servicing, to this.
Thank you, Abbas, for these clarifications. I'm considering the time a bit, and when I see a question from Florian Gandor, I have a feeling this has been already answered before, though similar to the question from Maria. So if you allow, I would like to move on. And I think the question from Tom Klingel has been answered by Abbas right now. That's why I allow myself to keep going. A next question is from Anders Steilein. Very interesting. How is your activity related to the ones of the Time Machine organization?
If I understand correctly, because I saw that message and question, but I wasn't sure that what that exactly means by the time machines into this. Because if it is related to the what we shown as a movement of the, for example, the vehicles or trams and trains, these are every 2 minutes time interval that we capturing information from the system, from the API that we get from the transport department into the feed into the system and interpolating in between to move But if it is related to something else, if you can clarify, we're happy to answer that.
Thank you, Abbas. I think we move forward to the question from Raphael Rollier. Impressive use cases, thank you. Are they all integrated into your digital twin platform, or do we have bricks and modules for each case? Can we use your tool ourselves as a product, or do we engage with you more on a research basis?
It can be used as a product, and it can be used as also engagement, and then we expanding that to fit for the purpose for any applications. So therefore, again, what we have tried to share with you some real cases and examples that actually already servicing, and also advancement of series of new dimensions into this. I think it is good that if you look at what are the priorities are from the market, and then if you see any appropriate elements, I think Dr. Daniel, we can answer and also respond back to you and provide more detail, or if the questions and anyone of colleagues actually have things on that, we can catch up later to address those elements. And also again, bringing back in general sense is the message that we wanted to share is these are the capabilities that now exist, and you can have that one, no need to waiting for another few years to have. So therefore, you can go ahead with that and have any type of ambition that you have. Let us we try and work together. And I again emphasize on that partnership arrangement, working closely with you and also with industry, private sector together, actually developing and demonstrating, and then going beyond what you have seen today. So any type of challenge you might have, or you would like to see capability to serving your communities or your clients, share with us and let us we explore that to see what we can do. One thing we have learned, again, we learned that we only can do things in a very close collaboration, and also we do together actually providing those kind of as a complementary skills to bring in that type of challenge, a solution for those challenge in the market.
Thank you very much, Abbas. Just to confirm what you're saying, I will show a last slide with our email addresses so we can stay in contact with each other.
Sure.
There's one more question from Régis Lanchon. What key performance indicators do you track to assess success of a digital twin?
Oh, that's a very, very good point. Different jurisdictions have different ambitions and plans and strategies. And again, going back to what Christine was indicating, for us, we see digital twin as a component, a part of your strategy, depending that how you want to achieve this. So therefore, the KPIs or the success stories, if you develop a system which is not going to be used by your communities, there is no success in that. So therefore, one of the success factor is we serving the market, and the market actually can expand and utilize this as a daily basis and getting into that. Bringing our communities with us, we work together on that. So therefore, the impact to the operation, minimizing the processes, reducing the time fractions, bringing new capabilities that we better serving, and returning the values on the investment that you're putting forward are the KPIs we are addressing. We're checking that to making sure that we bring the new lenses for the decision makers that we can look at. So therefore, for us, if we see our communities, our clients, our group that actually have the plan, and we provide an integrated solution, we provide them also with the fact and figure, and also we look at to reducing the cost, increasing their values, and return that, and also flexibilities, and also a dynamic nature into the system. I think that's another potential. That system should be dynamic, should be agile to addressing and also responding to your needs, because our needs is changing every time. And also because of the market, because of pressures, because of anything, and that we should be able to adjust ourselves along with that. And also leveraging of capabilities as open source and not requiring everything to be in-house. so you can actually again contribute as a building block to work together. So therefore, again, I'm emphasizing the partnership and then bringing each of us bringing a portion of it, and then together we build a better future for all of us.
Thank you very much, Abbas. I think that was a very fitting last word, because I think I should be wrapping up this colloquium because of time. There are two more questions, or rather remarks, which I think I would like to leave as they are there. Maybe that gives food for the next colloquium, who knows. But I would like to wrap up with this last slide that I mentioned. And here you will see all the email addresses from the speakers and from the team in Melbourne. With this, I would like to thank the speakers, Christine and Jörg Lüthi, and a huge thank you to the team in Melbourne. I think that was a very interesting insight that you gave us into this rather holistic platform. And I look forward to see the further developments and what will come out of it. So I wish you a well-deserved weekend. It's Friday evening for you, and I think it's a really well-deserved weekend. I wish all the listeners and viewers from Switzerland as well. Thank you for attending, and see you in the next event, next colloquium of Swiss Topo. With this, thank you very much, and see you later. Bye-bye.
Thank you very much
Thank you.
for the time and also all the wonderful questions.